Hi everyone. Today we're going to talk about right triangle trig. Mainly just kind of going over some basics in this video. Stuff you may have probably seen before, I'm assuming, in geometry. Trigonometry, it's really the branch of math that concerns specific functions of angles and their application to calculation. Essentially what we're going to do is we're going to talk about there's the trig ratios, excuse me, based on the sides of a triangle, and then how to find the angle measure. Then in another video, we'll do a little bit more application. So right triangles and the six basic trig ratios, SOHCAHTOA. So stands for sine, which is the opposite and hypotenuse. So if you're looking at it from where theta is here, this would be your opposite side, and this would be your hypotenuse. So that would give you sine. Ka is going to be what we call cosine. That's going to be your adjacent and your hypotenuse. So we're still using that hypotenuse, but we're using adjacent. Adjacent means beside, so it's the side that is beside our angle. And then TOA is putting them both together. That stands for tangent, which is opposite, and adjacent. And by using this, we're able to find out the side, or we might be able to find out the angle. Now, depending on what angle that you're actually looking at is where your opposite and adjacent are. So, for example, in your other triangle here, if theta is up top, then your opposite is going to be down below, your adjacent is going to be beside, and then your hypotenuse is always that side that is the longest. So, finding sine of an angle. Okay, so if here's an example. We've got the sine of 30 degrees. We've got cosine of an angle. Cosine 30 degrees is approximately 0.866. And tangent 30 degrees is approximately 0.577. These will change depending on which degree you're looking at. So for this is actually what you call a special right triangle, 30, 60, 90. And that's where they kind of get those from, being that if this is 30, then this is going to be x root 3, and 2x. And then you would do those different ratios. So for example, I'll just do sine here, but if I was going to do sine of 30 degrees, that would be x over 2x, which then simplifies to be 1/2, which is 0.5. There's also another special triangle as well, which I believe we'll get into a little bit later, but I'm sure that you guys know this one. It's the 45-45-90. This one is the 30-60, and that's x root 2. Those are the ones that you might not necessarily need your calculator for, but when you are using your calculator, you want to make sure that it is in degree mode. Okay, so if you need help with that, you can just let me know. If you're using TI, 83 or 84, you simply go to your mode, and then you look down. You'll find third or fourth down. You'll be able to see something that says like, okay, this is either degree or radian. Radian mode is a different type of mode that we'll kind of talk about a little bit later on through these lessons. So here's the first example. Find sine, cosine, and tangent ratios for theta in the simplest radical form. Again, make sure that you are doing these when you are doing them. It says simplest radical form, so we're not using necessarily our calculator. We're just trying to get the sine measures. So first off, I'm going to find sine of theta. Again, this is a video, so if you want to pause it first and do these, you can. Knowing where theta is, this is my opposite, my adjacent, and my hypotenuse. So it's going to be 1 over the square root of 10, which you can't have. You can't have a radical in your denominator, so you'll have to rationalize it. So you'll end up with the square root of 10 over the square root of 10, and then you'll get the square root of 10 over 10. Cosine that'll be 3 over the square root of 10, which again, you'll multiply, and you'll end up with 3 square root 10 over 10. And then tangent. Tangent is opposite, which is 1 over my adjacent, so 1/3 would be my final answer. Solving a right triangle means that you solve it for all the angles and all the sides. So essentially, you should have 3 sides solved for, you should have 3 angles solved for, and there's a couple different ways to do it. Trig helps, but you can also use Pythagorean theorem in order to solve, and then you can also take in 180 degrees in a triangle. If you have 2 of the angles, then you know right away that the other ones you can do for those. So it's important to work only with what you're given, because if you rely on a measurement you found in the process of solving to find the next side length, it might cause errors or rounding issues. That is 100% true. So when I'm solving this, I'm going to use 56 to start. I know that these are 90-degree angles. This is a 90-degree triangle. It's the only way this works with. I'm going to start off by trying to solve for side B. You really could do whatever you wanted to. But I'm going to say that the sine of 56, because if I'm looking at 56, this is my opposite, is going to be equal to B over 15. So then 15 sine 56 equals B. Off to the side here, I'm just using my calculator. And I get 12.4. I'm going to go 4. A cosine 56 is equal to A over 15. Again, I'm going to do the same exact steps. I'm going to move 15 over to this side. So 15 cosine of 56. And I'm going to get A is equal to 8.39. And then for up here, I'm simply going to take 180, subtract 90, subtract 56. And I'll end up with that angle being 34 degrees. And I also want to make sure that I label each of these because they are feet. That is how we solve a triangle. Say, for instance, though, we don't have 2 of the angles, and we are trying to find a third or one of the angles to kind of start, other than the 90-degree one that we're given. We can use inverse trig functions. Inverse trig functions are, if you look at your calculator, for instance, with tangent, it's the second tangent. That's what the -1 is, or the cosine -1, or the sine -1. So in this case, if I'm doing this, I've got theta is equal to the inverse tangent of 4/3. And I plug that into my calculator. And I'll get approximately 53.13 degrees. So here I'm given 2 sides, and I'm not given any of the angles, so I'm going to have to use that inverse. I'm going to start with my alpha. I'm going to go with cosine of alpha is equal to 19.67 over 37.21. So alpha is equal to the inverse cosine of 19.67 over 37.21. So alpha is going to be equal to 58.09. Then if I'm doing beta, I apologize, I must keep hitting something. If I'm looking at where beta is, that's going to be my opposite and my hypotenuse. So I'm going to do sine of beta is equal to 19.67 over 37.21. So beta is equal to the inverse sine, 19.67 over 37.21. And that'll make it so beta is 31.91 degrees. Right, and then last I need to find that third side. So a couple things that I could do. I could use one of those degrees if I wanted to, and then use sine or cosine. In order to find that, I can also use Pythagorean theorem, and that's what I'm going to do here. I'm going to use 19.67 squared plus a squared equals 37.21 squared, just so you get that different look. $386.9089 plus a squared one. Okay, so I'm going to subtract 386.9089 and then square root that answer. So A is going to be approximately 31.59 centimeters. Okay. So there are my three measures, and I was able to solve that triangle. Next up is application, which will be the next video.